Yeah, so much about one-shot recording. Anyway, let's play the buzzword bingo. So why are we doing all that stuff like machine learning, data science, big data, artificial intelligence? You probably have some kind of images and pictures, big pictures in mind, which are all about those buzzwords. And I try to give you my bigger picture, so to say, but that doesn't mean that, of course, because all that stuff is a little bit volatile and a little bit subjective. So it doesn't mean that your picture, if it's different to my picture, is wrong. There's no wrong or right in that case. But anyway, so why are we here? Well, because not only we are here, but also data is here. So data is everywhere. You know that. We have this famous saying, we are drowning in data, yet starving for knowledge. You can't do that. You can't do that so precisely in German, but anyway, so that's exactly the point. Yeah, we have so much large amount of data in many applications. So think about the web 2.0, by the way. So maybe many of you don't even remember what the web 1.0 was about. That was actually about, there were some web providers, web servers, and you could grab data from it, but you could not. So that was only unilateral in that case, yeah, unidirectional. You can only grab data, but you cannot provide data. And that changed actually, and that is the idea, or was the idea of web 2.0. I said, what? There were some kind of internet where I couldn't expose myself in a very embarrassing way. Yes, that was Web 1.0, and now Web 2.0 is bidirectional, meaning that also the user can provide data into the web for other users, of course. So think about YouTube, Instagram, and whatever. And of course that leads to just a flood of data. So much data is now available, and of course all that data has to be stored somewhere, has to be manipulated, processed somewhere, and of course people want to grab data benefits out of it. Yeah, so analysis should be also possible for that big data, and of course a manual analysis infeasible. So what people actually try to do is take one of those two possible solutions, descriptive modeling, meaning that we try to explore model characteristics, behaviors of observed data, which means that typically that is limited to some kind of hypothesis, and you try to verify or neglect the hypothesis. Yeah, but there is no standard way to really predict something out of it. On the other hand, you may have predictive modeling, of course, which is machine learning, data mining and stuff like that. So in that case, you want to predict the behavior of new data based on some model which is derived typically from other observed data in that case. So that is, of course, machine learning. So big data, we already mentioned big data here on the slide. So big data, of course, is in this context also a very important buzzword. Probably you know the term was originally triggered approximately 10 years ago by, interestingly, a McKinsey report. So some business administration guys had to come up and tell us informaticians, us database guys, how to actually deal with large amounts of data, and of course also how to grab information out of that. Yeah. At least they did something very good, which is they characterized big data. If you look at the characterization is not a definition, it's really a characterization. It's extremely fuzzy. Yeah. They came up with some fancy shit, which is some V's, volume, velocity, variety, and of course during the time people added more V's to characterize their idea of big data. I think the most important point is that big data is somehow a buzzword and a concept, of course, but there is no concrete definition what big data is. So if you ever have to justify in the company you're working in the future, justify to your boss that you are doing big data, think about it. Remember that there's no clear and hard definition, so it's more or less up to you whether or not you define your application to be big data or not. Yeah, because you will ever find any of those V's that are fulfilled, and because the V's are also very fuzzy actually. Yeah, so volume is one of the V's, of the traditional V's, but there is no, say, limit in terms of gigabytes or terabytes which defines actually volume. It's just large amount of data, whatever that means. Yeah? And that brings us to the second point here, big versus large. So it seems to be more a data engineering task, and actually at least 80% of the database community were a little bit pissed about this McKinsey report, but because what I was saying was there were some business administration guys telling the database community about what to do with large amounts of data, and also the data mining community. So at that time here in 2011, the database community, the flagship conference in the database community is the International Conference on Very Large Databases. And that happened at 2011, I think the 40th time. So almost 40 years, the database community already talked about how to deal with very large databases. And then some business administration guys came up and tell us, the experts, how to do it. Yeah? Of course there was a little bit a clash, but anyway, people actually came over it and used later on the term data science as a kind of compromise between the big data term and very large databases. So there was this joke on during that time on those conferences where people asked, what is larger, big or very large? But anyway, and of course there are related things like Industry 4.0, also a buzzword, but the idea is of course that you have these autonomous production plants where all the machines are networked and coupled and work smart together for the big deal of increasing money. But anyway, yeah, data lake, people don't know exactly what a data lake is. Data lake is a lake where you can put in your data. Yeah. Back when I was young, people pulled their trash into the lake. Of course, nowadays that's not environmental friendly anymore. So now people put data in their lakes. Okay, that's nice. Yeah, but data lake typically doesn't assume any specific technique, architecture, structure, whatever, any tools, but just that a data lake is typically something where someone can put data in, be it a NoSQL database, be it a relational database, be it a collection of Excel files or whatever. Yeah. Okay. So here is a nice picture from IBM. I don't get any money from IBM, but I just found this picture nicely, illustrating 4 V's here. But as I said before, people came up with different V's. I think there are, I'm aware of 10 V's actually. I cannot actually name them, but yeah. So, and maybe you can come up with your own V to describe why your particular data, your particular application is big data. Anyway, yeah, and then as I said before, data science is the more comprehensive look at all this. So data science is often considered to be the general process from data, collecting data, and then pre-processing and stuff like that, and then of course applying the fancy stuff, with machine learning, artificial intelligence and stuff like that, in order to gain really something out of it. Because you probably know already, but we'll see that later on, of course, that the path, the process from the raw data to some knowledge involves certain steps, from data management, data pre-processing, data engineering, and then of course data analysis, visualization, stuff like that. So and all the whole process together, I would say, is the data science process. Yeah. So the data science as a buzzword is a more general buzzword that considers the whole process from big data collection, managing, pre-processing up to making something out of it. Bing. Yeah, and has just a kind of holistic view on the entire process, as I just said, from raw data to knowledge. So here is a hype cycle where you see different things. The hype cycle is from 2016, 5 years ago. So still, here deep neural networks were just on the verge. Here maybe they are a little bit cooling down right now, but you probably know this hype cycle where things are hyped, and then they're cooling down a little bit, and then most of them get somehow consolidated, and you see R, for example, simulation, ensemble learning, whatever. Okay.